Alright, here's the notes for October 31st, Halloween. We're going to start with the bell ringer. So if the sub can just pause it, give the students 5 to 10 minutes to 10 minutes to copy these down and then answer both questions. This first one should not take long at all. Second one, after the 10 minutes, unpause it, and then I will answer both questions working them out. Alright, so hopefully it was paused. You got a chance to work it out. Number 1, it says fill in the blank for the definition of a circle. This is from Unit 1. Circle is a set of all points in a plane that is equal distance from a single point called the center. The second one, here's another abstract problem. You guys did great at first abstract. Let's make it a little harder. What is the slope of a line perpendicular to this line? So this line is not in slope-intercept form, so the first thing we have to do is put it in slope-intercept form. Now nothing's changing, so we first need to get our y term by itself. In order to get the y term by itself, I have to move this x term, so I'm going to subtract ax to both sides. These are not like terms. When you add or subtract, you have to have like terms. These are not like terms because there's no x attached to the c. So this becomes by equals negative ax plus c. Now to get y by itself, we're going to divide by b. When you multiply or divide, you multiply or divide everything. And we're left with y equals negative a over b x plus c over b. Now the question says, what is the perpendicular slope to this line? Here is the slope to the line. Perpendicular slope to this line would be a positive b over a. Opposite reciprocals. Change the sign, flip the fraction. Alright, now if you haven't already done so, the students need all 3 worksheets, all 3 pieces of paper. The 3 pieces of paper are all 2 in 1, so pass them out. They'll be able to cut them out. And then each student should have this, which should be a square. We're going to turn it into a foldable. An exterior angle theorem examples, and this foldable, which opens the wrong way. Not my fault. I didn't make this one. Just keeping you on your toes. Things opening backwards. Triangle sum, exterior angles, and other angle theorems. We're going to start with the square. So pause the video, hand everything out, let the students cut them out, and then unpause it when you're ready to go. This foldable, we're going to start with, is it a triangle? The triangle inequality theorem says that the sum of any 2 sides of a triangle has to be greater than the third. So when we find out, is this a triangle, we want to add any 2 sides, So 8 plus 17, any 2 sides has to be larger than the third. So is 8 plus 17, let's erase this, larger than 24? 8 plus 17 is 25. So yes, 25 is larger than 24. But you can't stop there. You got to try all of them. Obviously 8 plus 24 is going to be larger than 17. And 17 plus 24 is going to be larger than 8. So this does make a triangle. Let's go on to the next one. 3 plus 3, is it larger than 7? 3 plus 3 is 6. Is 6 bigger than 7? No. So this does not make a triangle. Any two sides, when you add them together, it has to be larger than the third. Last one, this is 41, 7, and 35. So if I add 41 and 7, that's definitely larger than 35. 41 and 35 is definitely larger than 7. So 7 plus 35, is it larger than 41? 35 plus 7 is 42. 42 is larger than 41. So it is a yes. So this is a triangle. This is not. And that is a triangle. Alright, so now what happens if you don't have all three sides? They say, what is the range, what is the possible range of the third side? You're going to do the same thing. You have to find all possible numbers, so you're going to write an inequality. That's why it's called the triangle inequality theorem. All possible sides that when I add it to 3 is going to be larger than 11. All possible sides or smaller than 11. Larger. All possible sides that when I add it to 11 is going to be larger than 3. So the way to get this done, 3 plus 11, you're going to add them. 3 plus 11 is 14, and then 11 minus 3, subtract them, is 8. So that means your range is x has to be greater, I'm going to write this, greater than 8 but less than 14. This will give you all possible ranges. Let's check it out. What's 8 plus 3? 8 plus 3 is 11. 9 plus 3. 9 plus 3 is 12. It's greater than 11. Go the other way. 7. 7 plus 3 is 10. It's less than 11. So as long as x is between 8 and 14, it will give you your triangle. For the second one, you have 28 and 31. Again, just add them. 28 plus 31 is 59, and then subtract them. 31 minus 28 is 3. So as long as x is greater than 3 but less than 59, that will create a triangle. Last one, 24 plus 7 is 31, and 24 minus 7 is 17. So if x is bigger than 17 but less than 31, that'll make your triangle. Any number between there will make your triangle. Next, ordering sides, and if at any point you need to pause or rewind this video, feel free. The shortest side is always opposite the, not shortest, the shortest side is opposite the smallest angle. The longest side is always opposite the largest angle. Order the sides from greatest to least. First we need to find the third side. To find the third side, right here, we're going to do triangle sum theorem, which is 59 plus 53 plus x equals 180. Triangle sum theorem. 59 and 53 is 112 plus x equals 180. Subtract 112 from both sides. and you get x equals, bear with me, I don't have a calculator. $68. Alright, so if this is 68, that's my largest. Order the sides from greatest to least. Across from the largest angle is the largest side. So EF is my longest side. The next largest angle is 59. Across from 59 is DF. DF. And then the last one, the smallest angle across from the smallest angle is the smallest side, DE. Ordering angles is just like ordering the sides. Across from the largest side is the largest angle. Across the smallest angle is always opposite the shortest side. The largest angle is always opposite the longest side. So it says order the angles from least to greatest. The smallest angle is going to be opposite the smallest side. So angle C is the smallest. Next one, angle A. And then the last one, the largest side, opposite the largest side is angle B. Do not worry about gluing this into your book anywhere yet. We'll get that done when I get back and see you on Friday. Alright, the next one we're going to do the triangle sum, which is a review, exterior angle, and other angle theorems that we need. So the sum of the measures of the angles in a triangle is 180 degrees. Find the measure of each angle. This says the three angles, I'm going to add them together. X plus 2x plus x plus 12 equals 180. And then we're just going to solve. I have x, 2x, and x, which gives me 4x. Then I have a 12, so plus 12 equals 180. Subtract 12, 4x equals 168. Divide by 4, and x equals 4 goes into 16 4 times, 4 goes into 8, 42. So C, since it's just x, C is 42 degrees. B is 2 times 42, which is going to be 84. And A is 42 plus 12. 42 plus 12 is 54. And there you go. Triangle sum theorem. Alright. The exterior angle theorem. The exterior angle here, this is the exterior angle, is an angle outside the triangle that forms a straight line with an angle inside the triangle. These two angles are always going to be supplementary. The angle outside and the angle inside the triangle will always be supplementary. The measurement of the exterior angle of a triangle equals the sum of the measures of the two remote interior angles. Two remote interior angles, well, if it's always supplementary to one, the one next to it These two are your two remote interior angles. So all you're doing is adding these and setting it equal to that. So let's try it. The angle outside the triangle, 2x plus 10, is equal to me adding together the two angles that do not touch it inside the triangle. This angle touches it, so it's not that one. It's going to be the two that do not touch it. So it's x plus 65. Now we have to solve this. Get all your x's on one side. So x plus 10 equals 65. Subtract 10, and x equals 55. This is find the value of x on done. If it wanted one of the angles, you would just have to plug it in. Alright, down here, other angle theorems. If two angles of one triangle are congruent to two angles of another triangle, then the third angles are congruent. Think about this. If two angles in one triangle are congruent to two angles in another triangle, then the third angles automatically also have to be congruent. Each angle of an equilateral triangle has a measure of, everybody say it out loud. No, you're wrong. 60 degrees. In a triangle, there can be at most one right angle or one obtuse angle. The acute angles of a right triangle are supplementary, which means they add up to, and I was wrong, that's not supplementary, that's the other word. Everybody know the other word? Say it out loud. Nope, keep going, not yet. Say it again. Complementary. Oop, fan blew it away. Supplementary is 180, complementary is 90. Again, if you need any of this replayed, pause it, rewind it, start it over. Now for the third worksheet. This one I'm only doing the first example. Actually, I'm not going to do any of the examples. You should be able to figure it out from your notes. Triangle sum theorem is this worksheet or this foldable here. Solve for the value of x and then list the sides from smallest to largest. Solve for x triangle sum theorem and then list the sides from smallest to largest. And then we're going to switch and do exterior angle theorem. The exterior angle is equal to the two interior angles added up, the two remote interior angles. If you have any questions, feel free to text me and I will try to respond.